Well, for number 3, we're given this cubic polynomial, degree 3 polynomial, and we're first supposed to find f of 2, which is simple. You just plug in a 2. And then we're supposed to find all of the zeros of f. Okay, so let's, and notice it doesn't say all of the possible rational zeros. You remember what the possible rational zeros would be? It'd be all the factors of the constant term over all of the factors of the leading coefficient, which is 1. So it'd be plus or minus the factors of 100 because it's over 1. So it'd be plus or minus, what would that be? 1, 2, 4, 5, 10, 20, 25, 50, and 100. I don't think I missed any, but that's not what we're being asked for. We want the actual zeros of f. All right, well, let's start off with f of 2. F of 2 is 2 cubed plus 3 times 2 squared minus 60 times 2 plus 100. Let's simplify that. That's going to give us an 8. This is going to give us a 4 times 3, 12, minus 120 plus 100. So notice that all of the positive numbers add up to 120. And then we have a minus 120. So what is f of 2? 0. Well, does that help us at all? We know that f of 2 is 0, which means that x minus 2 is a factor of f. So we could use synthetic division now and divide this polynomial by x minus 2. In synthetic division, that means that we put 2 in the cup. 2 is the 0. You set that equal to 0, and you get x equal 2. And then we take these coefficients, 1, 3, negative 60, 100. So 1, 3, negative 60, 100. And do our synthetic division. We drop down the 1. 2 times 1 gives us 2. Add the column to get 5. 2 times 5 gives us 10. Add the column to get negative 50. 2 times negative 50 is negative 100, and that adds to 0, which we knew it was going to be because we knew that x minus 2 divides evenly into this polynomial. All right, so what does this mean? We started off with an x cubed, so these three are going to be the coefficients of our x squared. So now we know that f of x is x minus 2 times, let's see, x squared plus 5x minus 50. Okay, so now we can factor this in our heads, I think. That would be x. It's got to be a plus and a minus, and the plus is going to be 5 bigger than the minus. So what do we multiply? 10 times 5 would give us 50. So if I make the positive 10 and a negative 5, when we multiply them we get negative 50. When we add them we get a positive 5. Great. So once we're completely factored like this, it's easy to write down the zeros. Set these three factors to 0 and we get a 2, negative 10, and a 5. 2, I'll write it as 2, 5, negative 10. Order doesn't matter, but so those are the 3 zeros. All right, so if we were going to graph this, which we're not going to, our first 3 points we would plot would be these 3 points on the x-axis, because these zeros are the x-intercepts. And we will be doing that in the next problem, number 4. Carefully graph the polynomial function given to us here. Well, notice this one's going to be a little bit easier to factor because we need to get the zeros first of all. Notice I gave some hints here. You don't have to answer these questions, but if you want, you can look at these. Find the x-intercepts, which we definitely have to do. For each one, does the graph touch or cross? And that's based upon the multiplicity of the 0, whether it's even or odd. Even would be touching, odd would be crossing. What's the y-intercept? That's a good point to plot. Plot additional points as necessary to sketch the graph, if necessary. Use the leading coefficient test to determine if we have a rise left or fall left, a rise right or fall right. So there are various ways we can do this. You don't have to just plot a whole bunch of, a big table of 10 or 12 points. Okay, well this one's nice because it'll factor by grouping, which we'll see here in a minute. F of x is x cubed minus 3x squared minus 4x plus 12. And the reason I know it's going to factor by grouping is I look at the first two coefficients. 1 over negative 3 is negative 1/3. Take the next two coefficients. Negative 4 over 12 is negative 1/3. So I know it's going to work. So I'm going to factor these two together and these two together to get x squared is the greatest common factor of those two times x minus 3. And then I need an x minus 3 in parentheses over here, so I'm going to put a minus 4. The common divisor of 4 and 12 is 4, and that would give me an x minus 3. If you distribute this out, you'd get negative 4 times x, negative 4x, negative 4 times negative 3, plus 12. So they came out the same, so factor by grouping works. And then x squared minus 4, which means we get x minus 3. This is the difference of two squares, so x plus 2, x minus 2. That's the factored form, so if we set that equal to 0, we'd end up setting all these equal to 0 to get that our zeros are 3 and then plus and minus 2. So 1, 2, 3, minus 2 and plus 2. Those are our zeros. All right, so let's go ahead and get the y-intercept. If you plug in 0, what do you get? 12. So our y-intercept is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But in the problem you get on your exam, it's possible that that y-intercept will be way off the graph, and I'm not going to require that you make it exact. But I want the shape of the graph to be correct. I want it to be rising where it's supposed to be rising, falling where it's supposed to be falling, going through or touching each one of these x-intercepts. So, notice that in the factored form, each of these has an exponent of 1. So each of these zeros has multiplicity 1, which means at each point it's going to cross through. It's never going to go touch and come back down or touch and go back up. It's going to actually cross through. So we really already know what's happening here. But we could use a leading coefficient test. We have a positive number in front and we have an odd exponent. So basically, what's the end behavior of this? If we just said g of x equals x cubed, we know what it looks like. Something like that. It falls left, rises right. So I know that this rises right and falls left. And I can see that this is going to go way up, way down. So that's not a very nice graph. It should be nice and smooth. But this, put arrows on both ends, that's all I really want to see that you understand when you graph a cubic polynomial like this. I want all the ups and downs, correct. I want it to be positive when it's supposed to be positive. I want it to be negative when it's supposed to be negative. That's the most important part that that I'm looking for.